Ahoy, mateys! In my last two articles, I showed you how to deploy microservice instances across several cloud regions and how to set up a geo-distributed API layer. All seems good, except that I've now got several standalone application instances running across the US West, Central, and East regions, and each instance has its own private IP address. My next challenge is figuring out how to forward application requests to the instances closest to the user. I don't want my web UI and mobile apps to keep track of all the IPs and decide how and where to route user requests. This is way too complicated and becomes unmanageable. Instead, the web UI and mobile apps need to connect to a single IP address, which lets other components of my geo-distributed solution decide where to route a particular user request. What could those components be, matey? You've guessed it, usually, a proxy and load balancer. In this article, I'll show you how to configure a global cloud load balancer that serves as both a proxy and a load balancer. This type of load balancer comes with a single IP address that can be accessed from any location on Earth and can route a request to the nearest active application instance. So, if you're still with me on this journey, then, as the pirates used to say, weigh anchor and hoist the mizzen, which means, pull up the anchor and get this ship sailing. Explaining global cloud balancer usage before diving into details and technicalities, let's use a few illustrations to see. Suppose Ms. Blue, one of my application users, is vacationing in the Tampa Bay area of Florida. She promised not to open my corporate Slack-like messenger, the geo-distributed app I'm building, while on vacation. She failed to keep her promise, but for a good reason. She couldn't resist sharing a few pictures from the pristine beaches of Tampa Bay. The diagram above shows what happens when Ms. Blue opens the app and sends a few gorgeous photos. The app connects to the global load balancer's public IP address, 35.186.215.175. Next, the load balancer determines that the application instance with IP 10.1.12.8 is closest to Ms. Blue. Both Ms. Blue and the instance are on the US East Coast. Finally, the load balancer asks the East Coast instance to upload the pictures. Next, Mr. Green, a colleague of Ms. Blue, working from his Seattle-based company office, receives a push notification from the messenger and can't resist checking what's been posted. Mr. Green opens the mobile app and the app connects to the same load balancer using the same public IP address, 35.186.215.175. This time, the load balancer forwards Mr. Green's request to the application instance from the West Coast that uses 10.1.11.16 IP address. Also, the load balancer is instrumental in case of cloud outages. Let's consider a final example. A few days later, Ms. Blue decides to make her colleagues jealous again and opens the app to send another set of fabulous pictures. The application connects to the load balancer on the same public IP address, 35.186.215.175, and, this time the load balancer forwards Ms. Blue's request to the application instance in the US Central with IP address 10.1.10.10. This is because a storm in the Atlantic impacted the availability of the entire US East Coast cloud region. The US Central region is up and running as normal, and is now the closest for Ms. Blue. So, the request is routed there automatically. Alright, matey, now let's move forward and look into the architecture, or the main building blocks, of the global cloud load balancer. Global Load Balancer architecture. The global load balancer is comprised of several building blocks. Take a look at the picture below and review the components from left to right. Thanks for watching. Please subscribe.